All right, so let's do some examples of actually solving the triangle given side-side angle. Okay, so um, the convention is, lowercase b is the side opposite the given angle. Uh, sorry, lowercase b is opposite capital B, and capital C is opposite of little c, and capital A is opposite little a. Okay. All right, so B is 70 degrees, and again, draw the picture here. Here's angle B, it's 70 degrees. So I have an acute triangle based on this angle right here. And the side that's opposite little b is 36. And you could draw C here or here, or sorry, you could label little c over here or here. But I want to put it here because I want to compare my adjacent side with my opposite side. Okay, so that will tell me how many triangles I'm going to have. So I'm going to put little c over here. It doesn't mean you can't do the problem if you put little c over here, but it's easier to make a judgment of how many triangles you can form. Okay, so based on this problem right here, before I do the computations, when it says solve the triangle, it just means find all the angle measurements, find all the sides. I'm going to compare, right? This is called the side that's opposite the fixed angle. This is called my fixed angle. This is the adjacent side. And so if the side opposite the fixed angle is greater than the side that's opposite, if the side that's opposite the fixed angle is greater than the adjacent side, which is right over here, right? The side that's opposite the fixed angle, this is my fixed angle, is greater than or equal to the adjacent side, I know I'm going to have one triangle. So that's why it's important not to just memorize in terms of A, B, and capital A, because, in this problem right here, I call this B right here, right? And in the notes, this guy right here is B. So this side is greater than this side, which is called the opposite side of the fixed angle, is greater than the side that's adjacent to the fixed angle. We know there's only going to be one triangle in this problem. Okay, so there's no ambiguous case. And once you've established how many triangles you have, then you can just use the law of sines. Okay, so you can write this ratio over this, or you can do 70, sine of 70 over this. It doesn't really matter. I typically like to keep my signs on top. So I'm going to say sine of 70 degrees over the side opposite, which is 36. And if you want to find angle C, which you recommend that you do because you're given little c, you would say sine of angle C is equal to 18. Okay, and then you cross multiply and solve for angle C. So cross multiply, this would be 18 sine 70 over 36. And to get angle C by itself, right, you take the sine inverse. So C is equal to the sine inverse of this number, 18 sine 70 over 36. Okay, and then make sure you are in your degree mode in your calculator. Okay, so I'll show you on the calculator. Here's mine. It's a little bit dusty right now. I'm going to hit second, make sure I'm in degrees. I'm going to hit second sine inverse. My inverse button's right here. 18 sine 70. Oops, 18 sine 70. And then, actually, I should probably insert some parentheses over here, okay? 18 sine 70. And divided by 36. Okay, so angle C is going to be about 28 degrees. I guess if you round to the nearest tenth, it's okay. You don't have to write 28.02. You could just say 28 degrees is fine. Okay, 28.0 degrees. Okay, so once you have angle C, right, which is 28 degrees, right, the measurement of angle A is just 90 minus 28, right, which is 62. So you have angle C, you have angle A. You already have angle B. So you have this. We still need to calculate what little a is, right? Little a is question mark. Again, you're just doing some cross multiplication, okay? So I'm going to say, now that my angle A is 62, I can use it in my calculations for little a. Okay, so I'm going to say sine of 62 over little a is equal to, it doesn't matter which ratio you want to use. You can use sine of 70 over 36, sine of 28 over 18, it doesn't matter. I'm just going to use sine of 70 over 36 is equal to sine of 70 over 36. Okay, so this is just a straightforward cross multiplication problem, right? A is equal to sine 70 over 36 times 1 over sine 62. Approximately little a on this problem, you'll get 37.9. Okay, there's no units on this one, so you could just write 37.9. Measurement angle A is 62, measurement angle C is 28. And that's how you find the find all the missing measurements of a non-right triangle using the law of sines, which is pretty useful if you don't have a right triangle. Okay, let's do another example before we hit up the more trickier case. Okay, so angle B is 40 degrees. I'm going to start by drawing my picture. Here's angle B. You don't have to draw it completely to scale, but roughly. And if this is angle B, right, my side that's opposite, we'll call it little b, is given to us as 4. And then A is A is 7, right? Okay, so we're given an adjacent side, which is 7, and our side opposite right here is 4. If we take a look at our notes right here, right? This will only be one triangle if the side that's opposite, which is little a, our fixed angle, is greater than or equal to our adjacent side. Then we know we're going to have one triangle, right? So right off the bat, right, this guy right here is not bigger than the side. And so it doesn't mean we can't form a triangle, right? The height, could be equal to the adjacent side or the side opposite. We have to compute, we have to compute what the height is to make a judgment on whether it's either one triangle, no triangles, or two triangles. Okay, so if you compute the height right here, you will be able to deduce how many triangles you can form. Okay, so let's draw down the height right here. And if you were to compute the height, right, sine of 40 degrees is equal to h over 7. H is equal to sine 40 times 7. And I'm going to approximately use my calculator right here. 7 times sine 40 is about 4.49. Okay, so if that's my height, right, which is about 4.49, and I took a look at my notes right here, right, if my height exceeds my side that's opposite, right, I'm going to have no triangle. And so right now my height is 4.49, and this height right here, which is 4.49, exceeds my side that's opposite my fixed angle. So you can say since h is greater than 4, no triangle. Okay, you could just stop. You don't even have to keep going with this problem. Okay, so the key right here is to do the comparison of these two sides right here. Once you establish that your side that's opposite the fixed angle is less than the side that's adjacent, you have to compute the height. And once you compute the height, you can deduce whether it's going to be no triangle, one triangle, or two triangles.